Alright, we're going to talk about finding the horizontal tangent lines. And to find a point where a function has a horizontal tangent line, first you need to find the derivative. And then once you've done that, you want to set it equal to 0. Remember, the slope of a horizontal line is 0. And please just only set the numerator equal to 0 and not the denominator. If you set the denominator equal to 0, we're talking about a vertical asymptote, not where the derivative is equal to 0. And you're going to solve for x, and once you have x, you want to substitute your x into the original function, and you want to find that y value. And once you find that y value, you can just go ahead and write y equals whatever that y value is, because a horizontal line is y equals whatever that y coordinate is. You have to be careful because not all x values yield a y value. If you don't get a y value, then just go ahead and throw it out. Alright, we're going to find the points, if any, where the function has a horizontal tangent line, and then we're going to write the equation of those tangent lines. And so let's first look at part A. I'm going to scroll down a little bit so we get a little bit more room. Alright, so I want to first take the derivative because I want to find what is my derivative. So I'm looking at f prime of x is equal to 3x squared plus 4x minus 15. And I want to set that equal to 0. And so if you have issues trying to find how in order am I going to factor this, I don't know how to factor it with I have an a other than 1. What you can do is you can factor by grouping. And the way that grouping works is you take your a and you multiply it by your c. So in this case I have 3 and negative 15. And so I'm looking at numbers that multiply to negative 3 times, or negative 15 times 3 is negative 45. So I'm looking at numbers that multiply to 45 and add to my b, which is 4. And so one of the easy ones I know of that are only 4 apart are 9 and 5. Well, I want a positive 4, so that gives me a negative 5, because 9 plus negative 5 is equal to positive 4. And so I'm going to take these factors and I'm going to split up, and this is called factoring by grouping. And so I'm just going to pick 9 in this case, 9x, and 5x. Those are my two factors, and I'm dropping down my 15 and my 3x squared. And as you can see, if I put together 9x and minus 5x, that should give me, if I go up, that should give me 4x, and it does. So now I have two groups. I have a group here and a group here. Out of my first group, my greatest common factor is 3 with an x. So if I factor out 3x, I'm left with an x. If I factor out a 3x from 9x, I'm left with a positive 3. My second group, my greatest common factor is negative 5. So if I factor out negative 5 from negative 5x, I'm left with just positive x. If I factor out negative 5 from negative 15, I'm left with positive 3, and that's equal to 0. And I hope you notice that I have the same group, x plus 3, x plus 3. Well, if I factor out my group, x plus 3, I'm left with 3x minus 5. And that's still equal to 0. So I'm going to set each of these. X plus 3 is equal to 0, and 3x minus 5 is equal to 0. That means x is equal to negative 3. In this case, x is equal to 5/3. Well, these are the x coordinates. In order for me to find out what my y coordinate is for that tangent line, is I have to plug these back into the original function. So I want to find what is f of negative 3 and f of 5/3. Alright, just using your calculator real quick, you'll get f of negative 3 is 50. And again, if I use my calculator, 5 divided by 3, plug that in, I'm going to get math enter tells me it's 22 over 27. And so these are your two tangent lines. Y is equal to 50. And y is equal to negative 22 over 27. All right, part B, I'm going to do the same thing, except for let me first, my coefficient is 2, and I'm going to move that t up, so it'll be t to the negative 3, and so now I'm ready to, ready to go ahead and take my derivative. So g prime of t is equal to negative 6 t to the negative 4. And if I simplify this, if it's negative exponent, if this exponent's negative, again, it means it's from the denominator. So I have negative 6, that's still my coefficient, but t needs to go back in the denominator. And I'm going to set that value equal to 0. Well, I have a problem because, again, I'm only setting the numerator, I'm not setting the denominator. And so there's never a case where negative 6 is ever equal to 0. So this can't be true. And so in this case, for g of t, for part B, there are no horizontal tangent lines. And the reason why that is because I have that negative 6 is it can't ever equal 0. Again, we're always comparing the numerator. Set the numerator equal to 0. Well, there's no way that negative 6 could ever be 0. And so since that's the case, there cannot be any horizontal tangent lines. Alright, number 2, let h be a function defined for all x is not equal to 0, and the derivative of h is given by h prime of x is equal to x squared minus 2 for all x not 0. Find all values of x which the graph of h has a horizontal tangent. And so my only restriction is x can't be 0. They gave me my derivative. And so what I have to worry about is just setting my numerator equal to 0. So I'm going to set h prime of x, which is x squared minus 2 divided by x. I'm going to set that equal to 0. Again, I'm not looking for where my denominator is equal to 0. I don't care about that. I'm looking at the numerator. So I have x squared minus 2 is equal to 0. Well, that means x squared is equal to 2. So x has to be plus or minus the square root of 2. And so those are the x values for which h has a horizontal tangent. Number 3, if a function f has a derivative of f prime of x is equal to the square root of 3 minus 2 sine x for all 0 x between 0 and 2 pi, find the x coordinates of the points where the function has horizontal tangent lines. Again, they gave me, so essentially because since sine and cosine are periodic, so meaning they're going to everything is going to repeat, they gave me a domain restriction between 0 and 2 pi. This is normal, and they already gave me my derivative. So they just want to figure out where is my derivative equal to 0. So I want to find where f prime of x is equal to 0. Well, that means I want to know where the square root of 3 minus 2 sine of x is equal to 0. So if I subtract square root of 3 from both sides, I'm going to get negative 2 sine x is equal to negative root 3, and then divide everything by negative root 2, or negative 2, not negative root 2. So I'm looking for at what values of x is sine equal to the square root of 3 over 2. Well, that means that I'm looking for values of x where sine is first positive. Well, sine's positive in quadrant 1 and in quadrant 2 because we're talking about the y. And root 3 over 2 means sine, if I'm looking at a triangle. I'm looking at, if this is root 3 over 2, I'm looking at for which side has, which angle has the longest side. Well, that would be a 60 degrees triangle. And so I'm looking at where are my 60 degrees angles in quadrant 1 and quadrant 2. Well, that means quadrant 1 would be pi over 3, and quadrant 2 would be 2 pi over 3. And that's all of our horizontal tangents.